Welcome to The Explainer. Today, we're going to break down a really cool idea that could completely supercharge solar power. It's an approach that takes thousands of individual solar panels and turns them into one single super smart network, making clean energy way more reliable and a whole lot more valuable. All right, so here's what we're going to cover. We'll kick things off with a big problem, a paradox really, at the heart of solar power. Then, we'll introduce a pretty radical solution called DePIN, look at a real-world experiment that put it all to the test, and finally, we'll see how it all cashes out with some powerful results and a serious economic payoff. Okay, first up, the solar power paradox. You know, we all see solar as this key piece of our clean energy future, right? But it's got this one fundamental, and it turns out really expensive problem. I mean, think about it. The sun, it's about as reliable as it gets. It's a massive, constant source of power. And yet, the energy we actually manage to collect from it down here on Earth can be incredibly tricky to forecast, not just day by day, but hour by hour. All it takes is one cloud drifting overhead to cause a sudden dip in power. Now, imagine that happening across thousands and thousands of homes. If the energy providers can't predict these swings, it creates real instability for the whole grid, and that gets expensive fast. And this brings us to a really key idea: imbalance costs. Basically, if a utility company promises the grid, hey, we're going to deliver this much solar power, but they deliver less, or heck, even more, they get hit with these financial penalties. It's literally the price they pay for being wrong. So, what's the root of all this uncertainty? Well, here it is. Every single solar panel out there is basically a tiny real-time weather station. But all of that amazing, valuable data, it's locked up. It's stuck in thousands of separate data silos. Because different companies don't share information, there are privacy hurdles, and there just isn't a good way to connect them all. So, how do you break down those silos? How do you get all that data talking? Well, let's dive into a whole new way of thinking about building networks, literally from the ground up. It's called DePIN. And instead of some giant corporation building and owning the whole system, DePIN is all about empowering regular people. In this case, anyone with a solar panel, to chip in for a common goal. It's a grassroots, bottom-up way to build a massive, powerful data network. This quote from the research really nails it. It's about creating this shared pool of information, a data commons, that helps everybody who joins in, and it gets around all those old-school competitive walls that kept the data locked up in the first place. And the model itself is just beautifully simple. So, step 1, you, a solar panel owner, agree to share your system's data. Step 2, that data gets pooled with your neighbors, making the forecasts for the whole network way smarter. And step 3, for your contribution, the network rewards you with digital tokens. Think of them like loyalty points for your data that can actually have real value. Okay, this all sounds great on paper, right? But does it actually hold up in the real world? Well, let's check out the evidence from this really fascinating study that put this exact idea under the microscope. So, researchers got their hands on real, minute-by-minute data from a group of 47 homes in the Netherlands. And their goal was super clear: figure out exactly how much better your solar forecast gets as you add more and more neighbors into this data sharing pool. To do this, they set up a bake-off between 3 different scenarios. Level 1 is your basic, generic forecast. Level 2 is better. It uses just your own home's past data. But level 3, that's the DePIN model. It uses your data and your neighbor's data. The big question is, just how much better is level 3? All right, now for the results. And believe me, this is where it gets really, really cool. This is the aha moment. Now, I know these graphs can look a little intense, but the story they tell is actually incredibly simple. The vertical axis is the forecast error, so lower is better. The horizontal axis is the number of neighbors sharing data. Just watch what happens to that red line as you move from 0 neighbors on the left all the way to 46 on the right. The drop is it's immediate, and it is dramatic. The second you start adding data from even a few nearby homes, the forecast for the entire area just gets massively better. It's proof. Sharing data makes the whole system smarter. Get this, at its peak, the network approach cut the forecasting error by a whopping 17%, compared to just trying to predict things on your own. In the world of energy forecasting, that is a huge improvement. And here's one of the coolest parts of the whole study. You don't need data from hundreds of houses spread out all over the place. The biggest bang for your buck, that sweet spot, comes from the first 10 to 15 nearby systems. It tells you that a dense, local cluster is what really matters for predicting things like a cloud passing overhead. That's the secret sauce. So, a 17% jump in accuracy is great. But what does that actually mean in the real world? Well, this is where it translates into saving some serious cash. And what's really interesting is that a solid improvement in accuracy can lead to an even bigger drop in costs. Remember those imbalance costs we talked about? Well, with these new, super-powered forecasts, those costs fall off a cliff. This chart shows the direct savings in euros, and you can see it mirrors that error chart almost perfectly. The reason costs drop even more is because the penalties for being way off are much harsher. So by eliminating those big misses, you get this outsized financial reward. And that reward is a potential 27% reduction in those painful imbalance penalties for the utility. A 27% savings just from people in a neighborhood agreeing to pool their solar data. That's incredible. Now, this chart is fascinating. It breaks down the value that each new person adds when they join the network. See that first tall blue bar? That's the value of the very first neighbor joining. They slash costs all by themselves. But now look way over to the right. The 10th person to join adds much less. This is absolutely critical because it shows you exactly how to design the incentives to get a network like this started. So when you put it all together, what you have here isn't just some clever technical fix. It's a complete economic engine. It takes all this isolated, almost useless data, combines it, and turns it into an incredibly valuable shared asset that saves real money. And that creates a clear, logical reason to pay people for their contribution. And you have to realize, this whole model for solar power, it isn't just about solar power. It's a blueprint. It's proof that we can build smarter, more collaborative systems from the ground up just by using the devices we already have. Imagine applying this to everything, from managing traffic with our cars to monitoring air quality with our phones. Which leaves us with one last big question. What problem would you solve first?